Good morning. And we are in one of the last days of the course. I'm not an expert in urban development. I'm not an urban developer. So if we have experts in the subject, I apologize for any mistakes. This area, the area of the urbanism, is an area in which geographical information system could be very interesting, but they are not being used. Not even in the architectural schools. They learn GIS. So I think that should change because that's really important. I know an architect in my neighborhood. And in order to make an introduction, I this is Benimaclet. This is a neighborhood of Valencia, and that used to be a village and was absorbed by the city of Valencia. So it has a core, which is still the old village. And there is an association in the neighborhood that gathered together in order to see how could they improve the urban development of the area. The idea was that the proposals that the neighbors they wanted to present them to the city council for them to try and implement some of the things they so the architect told me we could analyze the general situation of the neighborhood, and then we could analyze and compare how we could have this and I said, yes, we can do that, but I have no idea about urban development, so let me know what things should we analyze. And he said we should analyze things like parking spaces, trees, and other things that we think can be interesting for the people. We did a workshop with Latin Americans, and as far as we did this, for those of you who doesn't know, in the gvSIG blog, if you do a search urban development, you will see a post that is called book, in which we have a book that collects both the exercises that we are going to do here and the theoretical background for those exercises. You don't need to take notes because everything is very well documented, 50 pages. In this way, you can pay attention to this without the need to take notes. You can also disseminate it among all your friends, architects, and urban developers. And after you have all the exercises step by step. Let's start. Those of you who know gvSIG, how many people here didn't touch the gvSIG tool until today? Few, very few ones. That's nice. For those of you who doesn't know anything about gvSIG, perhaps you need some help. Please raise your hands and Mario will help you. We are going to use data related to urban development. Of course, this only has one intention, which is that you open your eyes to urban developers and the systems for geographical information, but thousands of possibilities exist. And when you get to know this software, then you start to know what you can do. Here you have selected the document view. We do that with version 2.2, and here we have the projection system, and that comes with a program which is 2346. There are very basic things that I'm going to mention for some of you. We are going to divide this into three different layers. We have a folder that is called Urban, which is the one that we are going to use along the workshop. Here we have two folders. You see 4326, and you have neighborhoods. And you have Axis Street, and you also have blocks. I could also like to say that one of the improvements that we're going to do for future versions are having a good access to the Gmail format. This is going to be the format, the exchange format for the cadaster, so that's why it is so important. I'm not going to get into much detail, but here you have the surfing tools, Zoom tools. As most of you know how to use gvSIG, I'm not going to insist on this. Here you can ask for information about neighborhoods, for instance. This should be active in the context table. You only need to know two concepts: able, disabled, and visible, hidden. And active or able, disabled. Here I put the San Pablo or Barrio de Vera, and it gives me information about that neighborhood specifically. One of the things that we can use basically, I'm going to remove the axis layer. I'll leave only the blocks layer. I open attributes on this layer, right button on this attributes table, and here we have population, total population, and then population by ages. I know that one field is numerical because text are on the right and figures are on the left, but you can change that with the field calculator and use chains. One important thing would be to do theme subjects. We're going to go to icons and we'll see how we have different ways of representing the same data sets. For instance, this here dot density that is defining a dot per each quantity I indicate. For instance, for blocks population, if I see the attributes, I see that in some cases we have 20, in other 30, in other 400. So then I say the value of the point is 20. So then it will draw 1 point per each 20 inhabitants. I'm going to give it a red color because it's easily it is a color that you can see very easily, and this is a visual representation. Or where do you have the highest density? It's very interesting in order to see the population density. There are areas in which clearly we have a very low level of population, and then we play with the value of the point, and it can be more or less clear. If I put 100, I'm going to see the areas where we do not have so much inhabitants. And well, it's a way of representing the population. Another one, a numerical value, would be by intervals, where you say the number of intervals that you want. You say the initial and the final color. I'll be able to define the exact intervals and making a double click. Perhaps for us, the interesting thing would be to have it from 1 to 100, from 101 to 200, and so on. We'll see that later. And then we can have a very interesting visual map the neighborhood in which we are going to work is here. You see that these are low houses and the population is less than 100 inhabitants per block. I'm going to leave that with a single icon as far as we are just doing a small introduction. And now we are going to start to work. I have cartography from the whole of Valencia, and I want to do a study of only one neighborhood. So I'm going to see the data that I need in order to work. This is basic for you. All data have been downloaded from the open data portal from the City Council of Valencia. They are free and public, and you can use them without any restrictions. If you get into the portal at the level of mapping, you can find everything. You have maps from social centers, bicycle parkings, all the interesting information can be downloaded. So that's very interesting for urban development, especially. In fact, I think we have here some people from the Valencia City Council. The first thing of all is to select the neighborhood in which we're going to work, which is Benimaclet, and then I have a tool which is a selection by attributes. And do you see here the icon of the funnel? And then here we have a double click in name, and then I highlight equal to, and then I make a double click on the area and the neighborhood I want to work with, which is Benimaclet. I could write name equal to Benimaclet, and that would be the same thing than making a double click. So then a new set, and you will see that this is selected, and then I can say that you should go to this zoom to the selection, and this is my working area. I have some blocks with which I want to work, and I'm going to do different operations so that you see that there are different ways to do the same thing in order to have a map of just my work area. First of all, is to export. I can export any layer, and I can say that the new layer needs all the elements, and I said active means that I'm to do layer or export A, and all the tools are in the same place, and you have different ways to run them. And here you have the same window that you had when you were exporting to KML. And here I say where do I want to save it. I'm going to call that neighborhood 1, Barrio 1. So that is easy to keep, and then I have to be to take care that I only want the selected areas. Then I can eliminate the neighborhood folder because I don't need that. I only need my polygon, but I have all the access, and you just click on this and draw, and this is a first step. And then we are going to use the blocks for a geoprocess. I could select all polygons manually. If I would have the attribute of the neighborhood, I could do a selection and an export, but as far as I don't have that, I can select a polygon by polygon, and it is easier to do a geoprocess a toolbox where we have all the geoprocesses that has like a wheel, and also we have in tools geoprocessing toolbox. I and here you have 355 tools, a lot of them. Then the best thing is to use the search engine. I want to cut a layer with the contents of another one. I want to cut those blocks with the neighborhood polygon, and then I search for cutting, and I can cut. I'm going to use this for vectorial layers cut. Then to run it, double click or right button and execute. And I have an entry layer, and that's what I want. I have a layer of blocks, and then I'm going to have the blocks which are inside the neighborhood. So the input layer, the block layer, I could say that the geoprocess should be run only on a selected object, and I can say that results should be saved in a temporary file. You know that the cut can be a point if it's a tangent and even a line. This wouldn't be so common, but it's possible. When we work with geoprocesses, sometimes we have different geoprocesses. So then you are doing all the intermediate geoprocesses, and then you export that with the final processor. Then we say OK, and it is cutting all the blocks in the city of Valencia. And if everything went all right, we will have a good result. Do you see that now? Now we have our blocks, and I can upload this layer, and those are empty, and they say no because they have no data. So then I remove them for the sake of clarity, and then I have a save file. The problem of a temporary file, you can edit, you can do whatever you want. The problem is that you save your project in gvSIG, and when you open it later, it's not there, because that's a problem with temporary files, that you work with them, but they disappear when you exit. So then you have to save it, the save file, and we can save that as blocks, whatever name you want, doesn't matter. Then all the records, and we insert it, and we erase that, and here we have the file that we want to do. Here we have the axis, and here we still have the road axis. For the whole of Valencia, we could do the same thing, a geoprocess for cutting, and perhaps it could be very logical, but so that you see other ways to do things, we are going to use the selection per layer that allows us to select the elements of a layer that have a special relationship with another. For instance, elements that intersect with which type of processes, which is what we used to learn in the school with data sets. Here it is important from the layer that we want to use as overlap, we have to select the elements that we want to use for the overlapping. So then I enable it, and with the different selection tools, I highlight them. Now it's yellow, highlighted in yellow. I put axis layer active, and within the selection menu, you will see that this is selection per layer, which is the one that we are going to use now. And then we have this window. And then I'm going to say that I want the ones that intersect with the axis that intersect with the selection of Barrio Uno, of neighborhood 1. I could have done that when I had also the layer with all the neighborhoods, with one neighborhood selected. Now I don't see anything because it has been selected in yellow. I don't know if you can see that. I'm going to change that color to a more visible color. And also the thickness. But you see that the selection has been done. We have all the axes that intersect with the neighborhood, the barrier 1 element that was previously selected. So what should I do? Export and export only what is selected. This is another way to do that. Layer export to. Here, oh, it's not active. So export to, that should be active. And I will call that axis 1, ejes 1. The selected record, if not, will create a layer which is very similar to the original one. And then I would have my 3 layers of the work area. You see that we have created them in different ways. One selecting graphically, another using geoprocess, and the other using the layer selection. 3 different ways that can be used in any case to form a map out of another. And we are going to create a new view and something which is very common, which is that we have information with different projection systems. For instance, the City Council of Valencia, which is in 326, and there is another one which is in 25830. When we have different projection system, if we do not reproject, then they will fall in different places. People that do not use GIS, it's sometimes difficult for them to understand how this works. The projections is the most difficult thing for them to understand. But the GIS goes from one type of projection to another automatically. I can go to properties or from the view menu, properties. Here I have the projection. And in type, it's going to show the last one that were used. In this case, I only used one because I installed that in the gvSIG. And I can check by SPG. In gvSIG, we have YAO 2000 that was for planets, I think, or something. And I don't know if anybody is doing urban development in the moon, but the ones that we use is the PSG. And as I know that is in code 25830, and then it finds it, and I say this is the one I want to use. One of the layers that I have created, for instance, Barrio, which was in 4326. What I should say in properties is that this layer is in 4326. Before accepting, once I said add, I go to properties and I say which is the original projection. That's going to be even easier in the next version because we will have a file which is called PRJ that is explaining the projection of each layer. So this will be detected automatically by the software. the type of transformation in this case is not necessary among other projections. We have other projections in which is necessary, and then you go to properties. Here you can choose the transformation that you want. You are transforming from one system to another. You should tell that depends on the case. You can use transformation in a PSG, and you have different options, or you have manual transformation, and you have different options. So you can either use two transformations or use the grid, and they are available in depending on the case. In this case, with the cartography, with the mapping I was using, that was not necessary. This is just for you to know. If I add mapping, which is in 25.830 in one layer, within urban 25.830, then I think in 3, in parking spaces, uh, is in 25.30, and you see that it matches. If I couldn't do that projection, then I'm going to add the barrio without saying that is in 25.30, but in the origin, which is 43.26. Excuse me. In this case, is doing it rightly, but if I add a layer in 43.26 and I don't tell the program that is in 43.26, this one of axis, then it's going to be out of place and it doesn't match with the other layers. So this is simply something that you should consider. The projections is something that you should know, because the Earth is round, and when we represent that in a flat surface, then you have to work with projections. So that's a must for us. Now we are going to do an exercise of this. We are going to create a new view in 25.830, and then we learn how to change the projection. Now it appears recent ones. And I have my view in 25.830, and we are going to add a series of layers. You go to the urban folder 830, and in parking, we will choose some layers related to parking spaces, and we will make an estimated calculation, an estimate of the number of parking spaces in the area. We are going to load Barrio Todo, plazas, parking spaces, finishing with Todo, all. You don't have to reproject because they are in place. And what I'm going to do, I'm going to change the symbology, and I'm going to increase the borders, and I would like to know this division. This area is the area which is the orchards the agricultural area, and the other part is the old town of Benimaclet, and the area which is between the two boulevards, which is the old village. And here we have icons. There is a quicker way to do, which is making a double click. But it should be active. A double click on it, and then this is opened, and I can change symbols. Uh, what I can do is this. If I do a zoom, you see that I have the different elements for different parcels, different plots. I'm going to view the attributes table. We're going to use it. And in this table, we have the cadastre data for the building. If it has seven floors, and what we have estimated is an approximation. So we estimate, we have here they have a basement or cellars 1 or 2, and that means that they have parking spaces, and based on this we'll calculate the approximate parking spaces that we have. I can put the table in edition. I go to table start edition, and I'm going to add a new field. I can add a column, and I have a button which is exactly the same, adding a column. This is a numeric field. I'm going to call it park. This is a numerical field, and it's of course we are not going to have decimals here. If I could put a defect number, that could be a bit different, and here it creates the field, and we're going to do an estimate. We see that there is an area field, and we can do an estimated. I do not remember how much was used, but they said that the parking spaces needs a series of square meters, 30 to 35. Okay, so which is the what is the formula that we can use? We can see the square meters divided by 30, and then we know how many cars or how many vehicles, so we can park everything which is less than 30 is not going to be here. It's at 0. And here we have a calculator that is used to do calculations, of course. And then based on that, we'll have the number of parking spaces that we have. So then we'll say that this is the area, the surface by or times the parking spaces here in the basement, divided with a symbol of division by 30. So we say okay, and the calculation is done. It says minus, but for me doesn't matter. I know that the minus, I'm not going to consider it, but if I want to change it, I change the field, and I say that -1 times the value of the field then that's multiplied by a -1, and then it's changing the sign. And then I know in which element, if I would like to know the total number of parking spaces, that would be right. I'm going to know in which spaces we should create more parking spaces and in which not. But if one of the things I want to know is the number of parking spaces because I have the data for the population in order to have cross information, I can use a statistic tool, which is the epsilon. I don't know if it's here a statistic table, and it says that we have 7,857 parking spaces. Whenever we do not have data, then we can find estimates. Of course, it's not the same thing as if in that layer we would have the parking spaces data. We have some error margin, but at least we have an estimate, an approximation. Then now we can do a theme map, right button properties, icons, and here we can speak about quantities, intervals, and what we have created. Five number of intervals, 5 intervals going from red to green. That means red when there are no parking spaces, and green when there are enough parking spaces. And the calculation is automatically done based on the data that goes 0 to 5, 6 to 30. 31 200 parking spaces. 101 to 200, and then from 200 to the last value. And here you have to change that in the label. You can put anything here where you have the values that are going to be considered, and then you can put anything. For instance, you can say less than 5, 6 to 30. So the text is free. 31 to 100. You see that we can write letters, numbers, 101 to 200, and here we should be 201, not 200. And here, for instance, more than 200. And it's apply. Okay. And I have my map where I see that in this neighborhood we had parking problems, to the exception of this area in which we have high blocks which have their own parking spaces in the building. Then for the rest, there are not parking spaces because these are houses which only have 1 or 2 floors and they do not have their own parking spaces. So there is a need for a public parking. The captions can be saved and used anytime. You see that we can save legend. I can save this when I'm working, and I call that parking, and then I have that that can be used in other layers. For instance, now I'm going to add other layers, which is called Aparca New, which is one planning. You have some polygons where it is planned that planning is going to exist. You could recover legend. I applied this legend that I just created. I know that there is no park a field, I should have to create a field that is called a park, and then I could add park integer integer numero entero is numeric, and I copy the values for the parking spaces. I have this here table, finish edition, save, and then I can apply this here. So then I can see which should be the simulation after building parking spaces here, or parking facilities. The values, you have them there in the caption. Less than 5, 6 to 30, 31 to 100, 101 to 200. Sorry, I can hear you. The attributes table, I put that in the same field, which is the same attribute name. Whoa. It had the data of the parking spaces, but I had no column that was called a park. I created a new column. It's a new field, field 1, that is integer and size 5, for instance. And then I highlighted, go to the calculator, to the field calculator, and I said copy here the number of parking spaces. And now, a very simple but very useful thing, we did this study, but we want to include this in a dossier. We are doing a Microsoft Office or any Office document, and we want to include this map. There is an option which is very simple in order to do that. View, export, export view and image. And then we are going to have a screen caption, and we see this, and we go to the workshop parking studio. A PNG, save, and if I go to another folder, I have my PNG, and I can insert this in the document where I'm working. And that's very convenient because for this you do not need a highly elaborated map. Sometimes you only need that, or if you are exchanging rapid information to somebody, a PNG, so that he or she knows the status, then you can do that in this way. You're going to create this new file icon. It says whether we want to change to save changes. In this project is not necessary, and then we just discard. Now we are going to work on the 3 number. We could do that also in order to study another value. Let's imagine some centers, health centers, and what we are going to do is a density map. But we could also do that for any other elements here. We are going to use three density. You yesterday or the day before yesterday, you saw how they were preparing maps with density of crimes. You can do that for many different things. We're going to change this. If you're always working with the same projection, it's not. It's a nonsense that you change the viewing preferences, which is this element with the key. In the view, we have the projection. If you have 25, 8, 30, then we would have that. But in order to practice, I'm going to make you change it. Properties, view in 25, 8, 30. It's going to be large. And we are going to add the layers. And then within the layer 25830, we see another folder, and it's trees. And now we will have the new one, which is called construct, and the other one, which is called area, which is the final one. I'm going to do the same thing, just to practice some basic concept. That of the area, I'm going to leave it without any filling color, and within within Benimaclet, this would be the old village area. The buildings, I'm going to put them without any filling, and the edges are going to be in a light gray. Well, not too light, because if not, the projector will not allow you to see it. But I don't want this to bother. So this is not the most important thing right now, because I'm going to study the tree density, and we could also change the icon of the tree. And here I'm going to put it in green, because it's a tree. I could also use some other icons from the library, which are much more spectacular, but it's enough with a very simple icon. Sometimes the GIS, for us, the interesting thing is this tree of that species is in this street. That's useful, but here I have an information just at first sight. What is very useful for these density maps is one which is called density. Easy to find. Density kernel. Then I execute and the geoprocesses manager, and if I know where it is, then I can do a search by name. I say that I want to make a density map, and if I put density, then I have two filters. There are two of them, and the one I'm interested in is density kernel. And I have this window here, on which layer do I want to do it? On the actual, which is a dot layer. You see that I don't have the polygon layer here. This has a sense if we want a ponderation. We know that some trees they are bigger in the canopy. Their canopy is bigger. So from the environmental point of view, it avoids pollution more intensively. So it eliminates more CO2. Then I create here a field which is coast, and the trees which have a value 2 is that this value is multiplied by 2. That means that they have more leaves and branches, and their canopy is more dense. And for instance, if I would be making a map for health care centers, then here I would put the number of beds or the number of resources. And here we are going to use the COSPE field. And now the search radius. What is the search radius doing? So here we have an image created, and the images have pixels, a series of columns, and each pixel is going here we are going to find we are going to assign this value. If at 50 meters we have 5 trees, then that pixel will have a value of 5, and it is weighted. If it is weighted, it would have a value of 10 because those trees have a value of 2 each, and then we could know who has one bomb, or this is a mine searcher. And the analysis region is interesting when we use raster, because we should tell them which is going to be the weight of that image, the space that is going to be used by this. And the cell size, I don't remember. And I'm going to put 10, and perhaps then we can reduce that because now everything is correct, and we say accept. So it's done quite quickly, and you see that you have a density map. I'm going to put that under the trees. This layer can be the deepest one, and it's okay, but it's quite ugly because black and white give us an idea, but to put that in our report is not the best image. And what can we do? Mario told us that we can apply a color table. This is a way of applying a legend, a caption to an image, in the same way as we can add legends or captions to vectorial data. We can also do something similar with images, depending on the trees that it has. Then the color is going to be different. So then we have the right bottom, and then we go to color tables. We activate. There is a box on the left-hand side, and here, depending on the color table that we choose, we'll have a more or less attractive image. I'm going to go down because I have this one red stripes, which can be nice for this. It's very similar to those heat maps that we see sometimes in the films. And I'm going to apply it. I see that the pixel size should have been smaller. What happens with this? And people usually doesn't know that the black color bothers me a lot to do my report. There are different ways to do that. I could remove the black color. There's a property between the raster, among the raster properties, that allow you to remove that. But there is another option which is saying that color 000 should not be drawn. I say and this is black. I'm going to deactivate and repeat the whole process. I go to raster properties, and I say that a specific color, if it would be white, it could be 255, 255, 255. But now it's black, and I said that for that color I want to have transparencies, but we are also going to show you this in a different way. I will apply the table, and another way, I don't know if you see the colors that they have uh, with the alpha, alpha transparency, and instead of 235, I put 0, and it's completely transparent, and that could be applied to any background. And now I put here the remaining active layers, and I have a very interesting map in which it is clear there are zones where it is excessive, and zones we have no trees around. This, uh, this I could export view image, and then I have my capture done there. We could do different tests. We could apply density to size 100, 200 to see different features. And now, what could I do? I'm going to say add layer, and here I have a layer which is called new, and I'm going to add this, and this would be the trees which are the sign for the new urban plan. I could do exactly the same and compare which would be the trees density in one or another case. I have the kernel density, coast field. I would use the same search radius, extension area, cell size, and we would do the same thing. Now I would apply the color table to this new layer. I apply the same color table so that it makes sense. And we see that the distribution is much similar, although there is still a concentration in an area, but it is much better. And these raster layers, for you to know, are temporary because they were obtained with a due process. So then I could export to save us and save them in a specific format of image, whether this is TIFF, EMG, if we want to have them in order to recover them once the project is finished. This has been done for trees, but it can be very useful for many different things, and not only for trees, also for any other density studies. Let's see another example. I'm going to add a new view in 25.830, if I'm not wrong. I don't remember. Let's assume I'm going to load this. In 25.830, and we create a new view in 25.830. This exercise is a bit silly, but I want you to see how things are done. I'm going to add the layers which are inside rhythm construction blocks. And excuse me, that was in 4326. So then view properties 4326, and there are three layers which are in 4326, which is blocks, noise, and mask. And this is an extract of the noise map of the city of Valencia. When we add this, it is loaded with a legend, with a caption. You should know that if in the folder where there is a layer, there is a legend that is saved with the same name. If we have been saving that with the same name, here you have it. The layer is called Ruido, and the legend is saved. Then when you load it, automatically this is loaded with that legend. I mean, with that caption. So you should know that geometries of this layer has very strange geometries, and doesn't allow you to do a proper cutting. I don't know how this layer is done, but it has geometrical errors. So if I want to do a caption of this, what I can do is to create a mask like this. And then I put a white color, and can be useful. And apparently I have my area, and I would avoid the filling, and I would have the noise map of the area. How did I do that area? Very simple. I did a new layer that was a rectangle, and I was cutting the work area. It's not so important, but I want you to know that sometimes you can find very simple solutions to solve problems. If you agree, let's do another exercise. Very interesting. I'm going to create a new project. I create a view in 25830. And I'm going to add, let's see, parking spaces. Within parking spaces, the G layer is everything, which is the layer for the access of the neighborhood. And here we are going to load neighborhood within a parka or parking. Imagine the case. Imagine that we have the plots, the blocks, everything. But sometimes we only have the axis, and we are going to do a representation of the blocks in which we add the official buildings, private buildings, and so on. For instance, the Penn Street map, for those of you who doesn't know that we have sometimes the mapping here. I would have the axis but not the blocks, because these are mappings from all over the world. And we are going to do geoprocesses to do some representations, and for that we are going to use geoprocessing. So based on the axis layer, one thing I could do, this is the neighborhood layer, the barrio layer. And I can make here an influence area. Here I could have, and this could be ideal, to have a field that gives me the width of the street in order to know which of these axes are streets or avenues or boulevards. So then, well, I don't know if it's correct or not, but I could have a street width of 8 meters. So I'm going to make an influence area of 8. You can find these in vectorial layers, or I can get the filter if I look for influence. Then an element generates an area of influence. Then I have the entry that can be executed in any area of the project. And if you have not created new project, then we'll have the whole list of layers. Now we could say, I could tell the software to use a numerical field in order to consider the distance to the area of influence. And if a street has a width of 5, I could use 5, and if it's 15 meter width, I could use 15. So 4 means that the street is going to make at 4 meters an area of influence, and at the other 4 meters the area of influence that simulates the street width. And that means I don't want to create a polygon per street, but I want a whole polygon that integrates all the other polygons, and I say accept. And that's dissolve. And I'm going to put that in light green. And what I have here is a unique polygon that represents the street and another polygon which is the neighborhood. I don't have the blocks just visually, but that's interesting. Now, what should I do in order to get the blocks? That's a question. Remember what you were told in the school. I have this set and this other set, and if I put them together, I have a common area, which is the common area of both layers. The area of influence is going to be the same, so this is not enough. If I take the underlayer, which is a full polygon, and I say to mark the common area, then these are going to be the streets. So what I need is the opposite, is the difference between both layers. This is not a question of GIS, this is geometrics. And we are going to look for a geoprocess between this 150 something, which is difference. It finds the difference for vectorial layers. And we see that this is exactly what we have, and we have the area of influence, and I want the difference. And which is the intersection, the influence area. Then you say accept. Here we have our block layer, which has been created almost from scratch. If I couldn't have the neighborhood layer, I could have created a new layer, more or less the area of work, which is a work polygon, and that's all. But this is not what I want either. And why? Because if I'm going to select a block, let's think that I want to erase this one, which is useless. If I select it, it's a unique polygon, is one single polygon. So as we had two neighborhoods, so we have two polygons. So what should we do? We are going to see if we find geoprocesses, and I didn't remember separate. Mm, I wanted to separate elements. Let's see if there is a geoprocess that separates. Yes, there is one. And this is difference polygon, which is the one we have obtained, and we have all temporary layers. So at the end, I'm going to export the final layer, which is the one that I want, and I am going to erase the rest of them because it's a nonsense to fill my disk with temporary files which I don't need at all. Now I could edit this and erase the elements. I don't want to modify attributes, add information in order to make my own theme maps. Sometimes it can be useful to have the centroid of the block and a dot that symbolizes the centroid of the block. How could you do the centroid of the block? First of all, if we know how we have obtained the layers, where would you go to find the centroid? Very good, to the toolbox. Whenever we need to do a process, where are we going to go? To the toolbox, of course. What do we want to do? A centroid. Centroid. We have a geoprocess to obtain the centroid. We are going to run it, and the layer is called result, the last one. We accept it, and well, this view is not going to be very nice, so I'm going to change the color and the size, and it will be much better. Here I have my centroid layer. These centroids and results. Then I would have here to work. It's available, and I can work with it. And for urban development, although you have seen with Mario how to upload icons libraries, there are some icons libraries which are very interesting. Then we go to tools, add-on management, because there are many of them for forestry management, for crime mapping, and it can be very interesting in order to do your own theme maps. So I'm going to filter symbols, icons, and here you have one which is Poi City. Poi is point of interest, which is very interesting, and OSM, which is the project I was talking you about, which is Open Street Map. They go in the distribution of GIS, but they are not installed by default. Then I have here this folder of icons, this library of icons that contains elements that we usually find in a city: a bank, a coffee shop, a bicycle parking space, trees, parks, um, metro or tramway, and also there are many items that can be interesting. For instance, we want to represent pharmacies, the pubs or restaurants of the cities, the churches. We have icons for everything. Now that we have this library of symbols, we are going to create our own view in 25830, and we are going to add a series of layers inside the Aparca folder, the parking folder. We can add a parcoche, which are parking spaces for cars, apartminus, which are for disabled people, bicycles, Valen For those of you who are not from Valencia, these rent bicycles, which are belong to the municipalities, and also the bus stops and taxi stops. If I add everything and I add the background layers, I could represent each element. This is in 4326, but for a theme map can be useful, and I could use symbols which are very useful. For instance, apart busy, I go to the symbology, and inside the ones I had, I could select this one. I provide the size which is necessary. It has one by default, but I can also have my business. It's not necessary that you make new symbols because you have lots of them. You have seen how can you create icon libraries, and in the internet also there is open and free icons libraries that you can copy, and there are a lot of resources which are free and open, and you can use them. So don't bother to do your own symbols. And here I could do a very nice map representing the different elements in my urban development study. Not all maps have to be with dots and so on. Uh, Parking spaces for cars. I think there must be a car somewhere here, and if not, I'm sure I'll find it. I'll find it here in transport. Parking car, whether is free or you have to pay. And it's very important that you know this part of icons. The same thing for taxi and EMT, which is the bus, urban buses company, and also metro. What else can we see? I think we have seen almost everything I would like to show you in this workshop. The hyperlink that can be very useful for urban development whenever you have some regulations that you have to link to each of the polygons or elements. But Mario already mentioned that. I think everybody was here. Is there anybody that was not present in the previous workshop? To one element, whichever it is. If in its table instead of a numerical value. For instance, I'm going to put measuring here. I add a new column which is called road. And here I have an address. We have an address. I don't know if we have something here. Home. The hyperlink is being run, but there was something wrong in the road. But it could open the right image. I have done that manually, and probably there was an error. The attribute editor is this one, which is when you edit, you can select any element and start to edit data. Yes. In fact, this utility is derived from Brazil, in which a company was doing an update of the cadastre for the city council. Then going to the table and editing that was very time consuming, and then you are drawing the data, you edit them, and you continue with the task, and that was much better. And that was the objective of the workshop. I wanted you to see how useful this is. Everything is documented. Then you have a complete manual, and there are free courses, including gvSIG. You have the mailing list, and I'm sure that we can really you can really find it very useful. Do you have any comments? So if you have no questions, I think that we are almost about to finish. So then in this session and in the meeting, we hope that you will come back next year, and we would like you to also present some lectures or some speeches about the work that you're doing with gvSIG.